Hello and welcome back to another episode of Math with So. Today we're going to be doing some area of regular polygons. And there is a simple formula that you could know, and the area of a regular polygon is 1/2 the apothem times the perimeter, which is convenient if you have the apothem. It's very inconvenient if you do not have the apothem. And the apothem, by definition, is whenever you go from the middle. It should technically be the middle, which all of these we're estimating that this is the middle. And then you go straight to the center of that regular shape. And if you do that, you're good to go. So in this case, our perimeter is referring to the perimeter of the entire shape. So we have 8, 8, and 8 here. And then we would do 1/2 the apothem, which is a very funny number this time, which is normal for the apothem sometimes to be funny because each shape typically has like a multiple of the perimeter to make the apothem as well, times the perimeter, and the perimeter in this case is 8 and 8 and 8, and 8 plus 8 plus 8 is 24. Okay? So you have a few options for how to do this. The first one I'm going to do is going to do it by hand because there's a chance that this might be needing to be done by hand by your teacher, but then I'll do it in the calculator too. So we're going to start by multiplying everything on the top, but not what's inside the radical. So we're going to multiply 4 and 24 together, and 4 times 24 is 96. And then we're going to multiply everything on the bottom, which is 2 times 3, which is 6. And notice how the square root of 3 just stayed there. If there was other square roots to multiply, I would do that. Now we can divide 96 by 6. And we get 16 square roots of 3 as our area. Okay? Next one. We got 13.9, and we have a few of these. 13.9, 13.9, 13.9, 13.9, 13.9, and 13.9. So if we add up those, 13.9, there are 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 of them. So 13.9 times 7 means our perimeter is 97.3 from 13.9 times 7. Okay? So we're going to do 1/2 the apothem, 14.4. times 13.9. Type it in our calculator. We got 0.5 times 14.4 times, I don't know why I did 13.9, times the perimeter, 97.3. I'm glad I caught that. And we get an answer of 0.4 times 14.4, I typed it in wrong, I'm sorry, times 97.3 is 700.56. Okay. So you may be wondering, why does this formula work? Because the formula is pretty easy to do. Okay, it's just 1/2 apothem times perimeter. But why does that work? And every regular shape, I'm going to use this pentagon here on number 4, can be divided. If you take the sides of it, it can be divided into triangles. So that triangle that I made right there. And then I could take this side right here, and I could get that triangle, and this triangle, and that triangle. And this is what I taught my students when I was doing it, because they weren't given the formula on the bigger test. I told them, divide your regular shape into a bunch of triangles. How many triangles do I have here? 1, 2, 3, 4, 5. Well, what's the area of a triangle? 1/2 base times height. They knew that. So if we do 1/2 the base, which would be 7.5, times the height, 5.1, that would be the area of one of those triangles. And how many of them do I have? I have 5. Well, what happens if I do 5 times the 7.5? I get the perimeter. Okay, so it's the same formula if you divide the shape up into 1, 2, 3, 4, 5 triangles, and then do 1/2 base times height, and then multiply by how many triangles you have. So I'm going to do that real quick. We have for one triangle 19.125, and we have 5 of them, so I multiply by 5, and if I multiply this by 5, I get 95.625. And if I had done 1/2 the apothem times the perimeter would have been 7.5 times 5 anyways. That's the same steps to get the exact same answer. Okay, so both formulas work. If you like to remember formulas, by all means, great. If you want to know why it works, that's why. We're going to do a few more. This entire sheet does not get very in detail, so I'm not going to spend a ton of your time on just going through every single problem like I normally do. We got 12 times 8. That would be the perimeter. Or it would be, how many triangles do I have? I have 8 of these triangles, but I'm going to make a mess if I draw them all. So 12 times 8 is the perimeter. 12 times 8, I believe, is 72. Nope, 96. 96. So the perimeter is 96. So if we do 1/2 the apothem, 14.5, times the perimeter, 96, we get our answer. And that answer is 696. If you want to be really specific, we haven't been doing this, but units squared if you want to be specific here. Let's do one more with a radical, and then maybe I'll do the critical thinking ones at the end, because these are going to be pretty easy other than that. So we have 1/2 the apothem, 5 square root of 3, times 10, times how many sides do I have? 1, 2, 3, 4, 5, 6. So it would be times 6. So either 6 triangles or 6D from 10 times 6 for the perimeter. So we're going to do 1/2 5 square root of 3 times 60. And I can either do 1/2 of 5 or I can do 1/2 of 60. 1/2 of 60 is 30. So I'm going to do 5 square root of 3 times 30. And then I only multiply what's on the outside of that radical. So that would be 5 times 30, which is 150 radical 3 as our apothem, as our area. All right. I am skipping all the way to the end. Actually, I might do some of these from 11. I haven't read this one yet. It says, use what you know about special right triangles to find the area of each regular polygon. Leave your answer in simplest form. So these are a little harder because we are not given the apothem. 18 is not the apothem. Okay, so this one I'm going to use my idea of, can I find this apothem that I just drew here, right here? That is the apothem. And it says use your information about special right triangles. So we're going to have to do quite a bit of work for these, and the video just got a little bit longer because of that, sadly. But if we have a regular triangle, each angle would be 60 degrees because you would take 180 and divide by 3 to get 60. And when we took the 18 and we had that diagonal going through here, each one of these would therefore be 30 degrees. Okay? So what they're saying is use your information about special right triangles. If we have a special right triangle with 18 here and 30 there, we have to think about what is going to be the length of each of these things. And there's a few ways to do it, one of which is with special right triangles. The other one is with trig. So if you are better with trig, it would be sine of the angle is equal to opposite, which I'm going to call x, over 18, and we multiply 18 sine of 30, which should be equal to 9. If you do not know that, then I would recommend either A, looking up my special right triangles video, or looking up my trigonometry video. So the apothem here is 9. And the other way you could do it, if you use special right triangles, this opposite of 30 is always going to be half of the hypotenuse. And then this guy right here would be 18 square root of 3, 9 square root of 3 if you needed that, which we do because the perimeter is needed. We have a smudgy 9 square root of 3. 9 square root of 3 is this half. This half would also be 9 square root of 3. And we can confirm that in our calculator because if we did 18 cosine of 30 is equal to the bottom part, and 18 cosine 30 ends up equaling 15.58. And you're like, whoa, wait a minute, that's not the same thing. Well, what happens if I type 9 times the square root of 3 in my calculator? I get 15.58. They're the same thing, okay? So both trig and special right triangles work here. If these are both 9 square root of 3 and you have 2 of them, the entire length of one of these sides would be 18 square root of 3. Okay? So 18 square root of 3 would be the one side, and we have not 1, not 2, but 3 sides. So 18 square root of 3 times 3 would be the perimeter. 18 square root of 3 times 3, 18 times 3 makes 54 square roots of 3. Now remember our formula, 1/2 the apothem, which is 9 times 54 square roots of 3 would be the perimeter. 1/2 the apothem times the perimeter. So if we type that in, half of 54 is 27, and 27 times 9, or you can type it all at once in your calculator, gives us a final answer of 243 units squared for number 11. All right, I'm going to do one more of those. That was rough. That was probably a very difficult question. And let's do another. So here we have the apothem. 4 square root of 3 is the apothem. Now we have to decide, what do we think these angles are? Well, let's think. We have a 1, 2, 3, 4, 5, 6-sided figure. You can do 180 n minus 2 divided by n to get that individual full interior angle. And if we do that, if we do 180, 6 minus 2 over 6, you get 180 times 4, because 6 minus 2 is 4, divided by 6 is 120 degrees. If you solve this, you get 120. Okay? So if this is 120 and we just cut it, we cut it in half, 60 and 60. And then this would be 30, and this would be nothing else. That's the only angle. So 30 degrees here. Okay, so let's think. What side do we need? Well, this is the longer side. I always do special right triangles for 30, 60, 90 special right triangles. We have the short side, which is here. We have the long side, which is there. And we are provided the long side is 4 square root of 3. The short side is just 4. The hypotenuse will be twice the short side. Okay? So that's the trick. Whatever side is the short side is the short side. The longer side is the short side times the square root of 3, and the hypotenuse is twice the short side. So we are provided the long side, so the short side, which we need, is just going to be 4. This is a lot to take in all at once. Again, if you're struggling with special right triangles, that's something that would be in its entire lesson. So here, also 4, which means that this combines to make 8. 8 all around. We got 1, 2, 3, 4, 5, 6, 8. So we do 1/2 the apothem, 4 radical 3, times 8 times 6, because the perimeter is 8 times 6. So 8 times 6 times 4 for all of the things on the outside, and times 1/2. If you multiply 1/2 times 4 times 8 times 6, you get 96 square roots of 3, ladies and gentlemen. And that's going to do it for this one. Until next time, stay positive, and I will be here for the next one. Bye.